I forgot to, gotta also share. Okay, welcome everybody. Thanks for coming. Let me tell you the plan today. Today's one of the easier webinars. Um, kind of the chapter we're doing, chapter 6, is a pretty simple one. I think you'll like that. I'll, as always, be happy to answer any questions you have. I listen in case you have a question you want to say. I also look at the chat box throughout the whole time, and I'm always happy to answer your questions. And after that, we're going to get into the normal distribution. Now, I know I've already mentioned the normal distribution, but we actually haven't done any computations with it, or not much. And we'll start out with standard normal distribution just to give you an idea of what happens. And this kind of uses the empirical rule. And we'll talk about what it is, what it looks like, all kinds of things about it. Then we'll calculate probabilities and percentiles with the standard normal distribution. Then we'll look at the general normal distribution, and that is going to require the calculator. And I do want to remind everyone, you are required to use the class calculator. Okay, if you're not using the class calculator, then I'm pretty harsh on grading. So you need to use the course calculator. And if you're doing, homework problems, whatever, that's, or discussion post assignment, that type of stuff, or exam, use the course calculator. That is important and required. And if for the project, of course, then you use the course calculator that is the spreadsheet calculator. So we're going to be using that for the general normal distribution, and we'll be calculating probabilities and percentiles for that. Then we'll look at a few applications. We're not going to do the main application of the normal distribution. Actually, you won't know why there's big applications until next week. So, going to have to hold off on it a little bit right now to let you know that, we'll do some kind of applications that are important, but the big ones start next week, and then we're going to basically apply the normal distribution for most of the rest of this class. Okay. Even if it's all under the hood and you can't see it, it's still using it. Okay, so that's the main goal. And again, this will probably be a bit shorter than usual. So hopefully that you'll be okay with that. But I want to remind you, this is week 4 webinar. What's important about the number 4 for the week 4 webinar or for week 4? Yeah. 4 is an even number. And when you have an even number, you have an exam. So I like to remind you that you have the exam. And let me tell you how these exams work, because now that we're in week 4, it's not, we have new sections and new chapters, and then there's old chapters. And all of the chapters are on the exam, but there's more focus on the most recent chapters. So that'll be chapters 4, 5, and 6. So definitely make sure you get this week's homework done, or this week's, I say, chapter assignments done before you do the exam, because the exam does cover a lot of the chapter 6 assignments. Okay, and you'll also want to look at the discussion post beforehand and look at all the interpretations that I've been doing. And just like the discussion posts, if I've said it's required to use certain words in the webinar, it's required to use those certain words in the webinar. And if you don't, you lose a lot of points. So just let you know. And I thought I was very clear about it last week, and hopefully you'll make sure that you use those certain words in the exam. So a lot of people did not in the discussion post assignment, and you lost a lot of points because of that. So that's just a note that, you are required to listen to the webinar and take notes. Make sure that if I say use those words for the exam, write that down so that when the exam comes, you can use it. Just like the week 2 exam, there's going to be some written questions at the end that are weighted more heavily than the individual questions. So make sure you're ready to do that write up. And again, if I say you have to use wording during the webinar, you have to use that wording. Okay. If you use AI, I'll know. And I could tell a lot of people were using AI, and that didn't go well. I took a lot more points off if I could see you're using AI. Even if I don't say you're using AI, I know. So that's just a big note. That's, to be careful about using AI because I can tell. And then I'm very harsh on grading. So the other thing I want to remind you is that a week from Sunday, what is due? What's the big thing due a week from Sunday? What's the big thing due? Yeah, Project One. And really, this is the week that you should be spending most of your time on Project One for getting the original write-up. So if you haven't already posted your idea for Project One, make sure you do that, and I will give you feedback. I've already done that on, if you those that have posted, and then you can make the adjustments that I suggest you make. Okay. And if you don't post your idea, then I can't tell you if it's going to be good or not because I don't even know what your idea is. But if you do post your idea, I can let you know that it'll work or that here's some little changes you need to make or make sure you think about this or whatever. So that is really important. Take a look and you can look at my feedback that I put on other people's ideas to find out what works and what doesn't work. So that's the main reason why I tell you you should be posting on the Project One discussion board instead of emailing me. So if you're emailing me, no one else can see it. But if you post on the discussion board, everyone can see it, and then everyone can get help from each other's discussions, if that makes sense. And the tutors are also always happy to help you out. Peter's here, and he'll help you too. Okay. Are there any questions about the project, about the class, about anything else? Always happy to answer. Any questions? If not, we can get to chapter 6. We get to standard normal distribution. I've kind of told you. Do you remember when I said normal distribution? Remember what that shape was? Do you remember the shape of the normal distribution that you kind of know from, past experiences? It's a curve. What kind of curve, though? All distributions are curves. Do you remember the shape? Here's a hint. Ding dong, ding dong. Not a wave, actually. It's slightly different than a wave because waves go up and down, up and down, up and down, up and down, and that's not what this does. So here's a shape. It's a bell curve. Okay, that's why ding dong. I tried to make it sound like a bell, but maybe I'm not good enough at it. But yeah, it's a bell curve. So that's the shape of the normal distribution. And there's some very important things about this shape. This is what's called the standard normal distribution. And what that means is the easiest normal distribution you can make. So notice that the mean is 0. So the normal distribution is symmetric. So the mean and the median are the same. So right in the middle is the mean, and that's the 0 right here. When you have a standard normal distribution, the mean is 0. And the standard deviation of the standard normal distribution is 1. That's the standard deviation. And then we had the empirical rule that said the probability of being between -1 and 1, or the empirical rule says that 68% of this curve, of the area under the curve, lies between -1 and 1. 95% lies between -2 and 2. And 99.7% lies between -3 and 3. Okay, and it does keep going on, but it's like very, very small percent chance after that, right? If you have a 99.7% of being within -3 and 3, it's not very likely at all to be like at, past 4, for example. It's really, really rare for that to happen. Okay, any questions on the standard normal distribution and what it looks like and what they call sometimes the 68, 95, 99.7 rule? You can call it an empirical rule, but if you use the numbers, then you'll know the important part of it, and those are the numbers. Any questions on that? Okay, so now let's go do some probabilities. Okay, let's find the probability that if you randomly select something under a normal distribution, that that value, let's call the variable for that, is a standard normal distribution, that value is somewhere between -1 and 1. Okay, I want to show you something that's really important. The kind of way of writing down the distribution is you write z, that's the variable in this case. And then remember this little thing that's tilde? And that's kind of a shift next to the left of the one. And that gives you the tilde. And then n for normal, 0 for the mean being 0, and 1 for the standard deviation being 1. So 0, comma 1. We want the probability that z is between -1 and 1, so we can write p parentheses -1 less than z less than 1 and parentheses. What does that equal to? The hint is this should be easy. It's our last super easy one that we have. Close. It's not 68. It's very similar, but you left something out. The probability can never be 68 of anything because 68 is too big. Can never be bigger than 1 for a probability. So you're close on the 68, but you forgot something. Remember? So 68%, you need to turn it into a decimal. That's 0.68. Any questions on that? So the probability that z is between -1 and 1 is 0.68. Any questions on that? Not too terrible, right? Okay. So then let's do another one. Find the probability that z is less than 3. So here's 3 over here. You think that one's going to take some work. Any ideas on how you might come up with the probability that z is less than 3 without using a fancy calculator? You might have to do some basic arithmetic, but no fancy calculator needed. Any thoughts? Okay, I don't see y'all jumping in, so let me show you the strategy. Okay, it's not quite 0.997 over 2, because 0.997 over 2 would be that z is between 0 and 3. Do you see? Because 0.997 is between -3 and 3. Divide by 2, that'll be half of that, between 0 and 3. But we want the probability that z is less than 3, which is all the way off as far left as you can go, past -3. So what we can do is we can say, well, between -3 and 3 is the 0.997. So I'm going to take between -3 and 3, and that's a piece of the area. But then there is to the left of -3. Any questions on that? Well, if 0.997 is the inside part, 1 minus 0.997 is the outside part. Any questions on that idea? But the outside part is to the left of -3 and to the right of -3. Now it's symmetric, so if we divide by 2, we'll get just to the left of -3. So I'm going to look at 1 minus 0.997 divided by 2. And that'll give us that really tiny far left part. Add that to 0.997, and that'll give you the total area. And that is 0.9985. Any questions at all on this example? Any questions? Okay. The next question is find the probability that z is between -1 and 2. So -1 to 2. And again, you're going to use this stuff, but you have to, do some a little arithmetic stuff. Basic. Okay, so the idea, if we want z between -1 and 2, we can say that's the probability between -1 and 1 plus the probability between 1 and 2. Now we could look at that and say, well, between -1 and 1, that has a 0.68 probability because that's what it says. 68% is between -1 and 1. Any questions so far? Between, so that's between -1 and 1, but we need also between 1 and 2. So the way you do that is say, well, if you look at this between 1 and 2 and between -1 and -2 together, that's going to be everything from -2 to 2 minus everything between -1 and 1. And it's symmetric, so if I divide by 2, I get this one piece between 1 and 2. So I'm going to take 0.95, that's the between -2 and 2. And then I'm going to go minus the 0.68 between -1 and 1 and divide by 2. So that'll be this bar right here between 1 and 2. I add it to the bar between -1 and 1, the 0.68. So I get 0.68 plus 0.95 minus 0.62 divided by 2. And that gives you 0.815. Have I lost you, or are you following how kind of piecing together? And there's a lot of piecing together in this stuff. Any questions? Okay, if there's no questions, let's go to the next one. Okay, so find the value of z such there's a 2.5% probability of being greater than this value of z. So, by the way, is that value of z going to be far left or far right? If there's a 2.5% probability of being greater than this value, is it far left or far right? Yeah, that one's far right. Because if only 2.5% of the people are taller than you, you're tall. Is that clear? So, same idea. So, somewhere in here, we're going to have a value of z. We don't know exactly. It could be here, 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 here. And there's a 2.5% probability of being bigger than that value. Now, again, symmetry happens a lot in this stuff. So if there's this little right tail, they call it, has 2.5%. Then if I go to the mirror image on the left tail, that's also 2.5%. All right. If there's 2.5% on the right, 2.5% on the left, that if you add those up, that's 5%. 2.5 plus 2.5 is 5. So if there's 5% outside, how much percent is inside? So 5%, yeah, 95% is inside, and that's good because that's one of our special numbers. So if 95% is inside, that means that our boundaries are -2 and 2. But we know that we're on the high side. So the answer's 2. Any questions on the idea there? So a lot of visual geometry involved. It is important that you get that down. Any questions? Okay. Let's do another one. Oops. Okay, let's find the 16th percentile. Do you remember what it means to even say 16th percentile? Are you a large number or a small number if you're 16th percentile? Are you left or right? So are you on the left side or the right side? Yeah, you're on the left side. So 16th percentile is going to be on the left side somewhere out here. What that means is 16% is to the left of you. Okay, and again, if we take that mirror image and say 16% is to the right of its mirror image, 16% plus 16% is how much percent? 32%. Now, if there's 32% on the outside tails, how much is inside? 68%. Okay, so we can restate this by saying 68% is between what numbers and which one is on the left? Well, 68%, there we go. That's between -1 and 1, and the left-hand side is -1. Do you see? It's kind of logic. Any questions on that? Okay, here comes the next question. Okay, now if z is 1.3, find its z-score. Let's see if you can do that. Put in the chat box the answer to that. The hint is it's really easy. If z is 1.3, find its z-score. Okay, looking for a number. The hint is it's really easy. Okay, I don't see y'all jumping in, which means I think you don't know what to do. So remember the z-score, by definition, was our value minus the mean, all divided by the standard deviation. What's the mean of the standard normal distribution? I've already said it. What is the mean? 0. What is the standard deviation of the standard normal curve? Is 1. So that means all you have to do is you know that z is x minus mu over sigma. Okay, our x in this case is our z, 1.3, minus 0 divided by 1. And 1.3 minus 0, I hope you can do that without a calculator. That's 1.3. And then 1.3 divided by 1, I hope you can do that without a calculator also. It's 1.3. So the reason we actually use the letter z for the standard normal distribution is it is its own z-score. Any questions on that? Okay, so the next one, now we're going to have a new one. We're going to have a bunch. Okay, now suppose that x follows a normal distribution with mean 114 and standard deviation 23. Find the probability that x is between 100 and 120. Okay, so I will let you know, now we do not have a standard normal distribution. So there is no way you're going to be able to do this by hand. Any guess on what we're going to have to do? Any thoughts? Yeah, we're going to have to go to the calculator. And again, you're required to use the course calculator. Okay, which AI will not use the course calculator, and I can tell. So you're required to use the course calculator. Which calculator number do you think we want to use? Again, we'll do things in order, and it should be obvious. Yeah, number 9, normal probability. So here is what it says. And it says P of X, we have a less than, a greater than, or a between. So again, we want the probability that X is greater than 100 and less than 120. So I click on the less than, the greater than, or between. Hopefully it's obvious. Which of the 3 we're working on? Because you do have to know how to use this calculator. Greater than. Let's take a look at this. This is not just x is greater than a number. There's that 120 also. Okay, x is less than 120 and it's greater than 100. If it's both less than and greater than, what is it? Between. And now a new area comes out, and it's between 100 and 120. So I go 100 and 120. The mean, okay, the mean is 114. And the standard deviation was 23. Any questions on this? And I click calculate. Okay, and there is a probability. It also gives you a nice picture. So there's our normal distribution. There's our mean at 114. We want to be between 100 and 120. And that has a 0.3315 about. If you want more decimals, you can look at this huge, many, many decimal places. And there's our probability, 0.3315. Any questions on that? Okay. By the way, you are required to use our calculator, the course calculator. Okay. So that is a requirement. If you use AI, it's gonna talk about it differently, and I can tell. Just let you know that. Do not use AI to answer any question in our class. Okay? You can use it for learning, but not answering questions or doing any work. Okay, we want the probability that x is greater than 200. Okay, what changes now? Yeah, now we hit the greater than, and it's 200. The mean hasn't changed, the standard deviation hasn't changed. We don't know the probability, so I leave that blank. Whatever you don't know, you leave blank. And I hit calculate. And it's a really tiny probability, 0.00004 zeros and 9233 about. 9233, yeah. 923, yeah, 9233. Any questions on using the calculator so far? I tried to make it easy, but you have to practice a little bit to learn it. Okay, now the probability that x is less than 90. What changes now? Yeah, now we want less than. And I go 90. And I leave the probability blank. That's what I don't know. And I hit calculate. And about 0.1484. Any questions on any of these? Are you agreeing that this is one of the easier chapters so far? Have I done anything that's really hard to kind of do? Yeah, I think this is one of the easier ones. Okay, and there's not too much left actually. So again, you should be able to do all these probabilities. Let's do some more. Let's do this. Okay, so let's find the probability that x is greater than 105 given x is less than 125. So now you have to go back to chapter 3. Because when you have a given, we had a little formula. And that was the probability of A given B was the probability of A and B divided by the probability of B. So I'm going to use that formula. Okay, A and B to be greater than 105 and less than 125, that means you're between 105 and 125. And then divided by the probability of B, probability of X is less than 125. So let's first find between 105 and 125. So now between 105 and 125. We don't know the probability, so I leave that blank and hit calculate. And you get about 0.33598158.5, etc. So that's how I got this 0.33598. And then we got to divide it by the probability that X is less than 125. So now we have less than 125 and erase the probability. And that gives you about 0.6838 or so. Okay. And then divide, you definitely need a calculator to divide that, and you get about 0.4914. A little less than half. Any questions? Any questions at all on part D? People have a lot of trouble sometimes because they got to remember chapter 3. And chapter 3 does come up. Okay, let's go to part E. Let's find the IQR, interquartile range. And if you remember, that was Q3 minus Q1. Do you remember what Q3 means? Yeah, what it means is that there's a 75% probability of being less than that value. So what I can do now is I have a less than, the probability is 0.75. What we don't know is the value. That's this 125. So I leave that one blank this time because that's what we want to find out. Any questions on leaving that blank? Okay, then I hit calculate. And when I do that, I get 129.51 or so. And then minus Q1. What changes when I want Q1? Yeah, the probability is now not 0.75, it's 0.25. And again, we don't know the value, so I'm going to erase that. And I hit calculate. And you get 98.4867. And I'll just call it 0.49 just to make it easier. And then you just do the arithmetic, right? That's what, 31.02? Hopefully I did it right, I did it in my head. Any questions on that? Okay. Let's look at the next question. The middle 84% of the data is between what two values? Okay, that one's going to take a little thinking. And the problem is that you can't leave two things blank on the calculator. You can only leave one item blank. So what you can do is say, basically do what we did with the standard normal distribution. If there's 84% in the middle, what percent of the outsides? 84% in the middle, what percent's the outsides? 16%. Now, if there's 16% on the two outsides, what is the percent on the left side? So what's the percent? It's a 16% on the two outsides. What's the percent on just the left side? What do you get? So 16% on these two, then the left side is only half of that, not double, half. So it'll be 8%. Is that clear or is that confusing? Because if my two hands have 16%, then only one hand has 8%. Do you see? 8% each. Okay. So that's 0.08, by the way. Always important to know how to take percents and turn them into decimals. Okay. So 0.08 is the left. Okay. That's our probability of being on the left. We want the value. And I hit calculate. And you get 81.68 or so. Any questions so far? So 81.68 was the left-hand side. For the right-hand side, there's a few ways of doing it. I think the easiest is saying, well, the right-hand side has 8%. That means that we can say greater than 0.08. So there's an 8% probability of being greater than some number, and that'll be 146.32 or so. So that's the two values that it's between. It's between 81.68 and 146.32. Any questions on that? Okay, another one. I have a lot of these. Okay, find the z-score for the value of x equals 117. Okay, and that's just plugging in z equals x minus mu over sigma. X is 117. X is 117. Mu is 114 because that was our mean. That was up here. Our standard deviation was 23. So we divide by 23. 117 minus 114 is just 3. And I get 3 over 23. If you want to stick in the calculator, you can. Any questions on finding the z-score? Not too bad, right? You don't need any fancy calculator for that. All right, you ready for an application? All right, so now here's kind of a fun little scenario. All right. Suppose that the time until you or your wife, if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay. By the way, if the mean is 140 days, what do you tell people? Because most people don't even know what that means to say the mean is 140 days from when I'm going to give birth. What's the word that people use in English? You've probably heard it. People would say, "When are you expecting?" And that's when you're expecting. You're expecting in 140 days. And that is the mean. Does that make sense? Okay. The standard deviation is 7 days. The interesting thing is it is normally distributed. It actually used to be normally distributed, but it isn't anymore. This isn't math, but any guess on why the distribution of birthdays is not normally distributed anymore? There is a reason. I don't see y'all jumping in. C-sections. So now if you're way past your due date, they just pull out the baby. And that's just the way it happens. Okay. But we're going to pretend you're going to have a natural birth. So then you can really do say, and then the standard deviation really is 7 days. Okay. and the mean is 140. You're expecting in 140 days. Sound good? So the way we write this is x tilde n 140 comma 7. So x has the distribution that is normal with mean 140, standard deviation 7. To write it in this format allows you to take this whole long sentence and just see it in a little area. So that's why I like the format is makes it quick and easy to see. Okay, now here we go. Your boss has just scheduled you or your wife, okay, for a business trip out of the country. Okay, you or your wife leave today, and you're going to return in 135 days. Find the probability your baby will be born out of the country. Okay, how do we do that? If the baby's born out of the country, what does that mean? Okay, we don't need z-scores actually. What do we need? Okay, what we need to do is we need to find the baby was born out of the country. If the baby is born in less than 135 days from now. Does that make sense? And by the way, zero is so far from 135, you don't have to worry about, assuming, hey, I know that it hasn't been born yet, but you don't have to worry about in this case. We'll get another one like that. Okay, so we want the probability that x is less than 135. We have a normal distribution. So we just go into the normal calculator. We have less than 135. We have the mean was 140, standard deviation is 7. And we want the probability. And there we go. About a 23.75% chance. 0.2375. Okay. By the way, let's just suppose it may not be true that, hey, you'd really love it if your child became the president of the United States when your child, was a lot older. Um, but it's born out of the country, you can't be president. I don't know if you know that, but you have to be born in the country. Um, so you don't want, and besides that, maybe, where you're going out of the country has terrible medical care. So you want to make sure that that doesn't happen. Okay. Are you okay with a 23.75% chance of it being born out of the country? What do you think? Is that a tiny chance or is that a significant chance? What do you think? Would you be okay if it was born, if there was a 23% 0.75% chance? Okay, the idea is that's a pretty big chance. Okay, and you want your baby born near you, where you live. So you're going to negotiate with your boss. So here's the deal. You decide it's too risky. You want to negotiate with the boss to ensure there's no more than a 1% chance the baby will be born out of the country. Okay? What day should you ask for the beaver the return date? Any questions on the question? Okay, so now we say the probability that X is whatever the day that return date might be, is X is less than that date, is 0.01. Let's find that date. Any questions on how I was able to take that word problem, turn it into symbols? Okay. So we want the probability to be 0.01. And it's less than what value? And I calculate. That's 123.7 or so. So you're going to ask your boss, can I return in 123 days? Right? You're negotiating. So even though it rounds to 124, you're like, nah, I want it to be less than 1%, not a little bigger than 1%. Do you see? Because it's no more than 1%. Any questions on that? All right. Now let's suppose it's 138 days later and your baby still has not been born yet. Find the probability that the baby will be born within the next 24 hours. What kind of question is this? What are we going to have to do for this? Any ideas? I don't see y'all jumping in. See, we know the baby was not born in the first 138 days. So this is a conditional probability question, a given. So we're going to say probability that X is between day 138 and 139, given X is greater than 138. And then we go ahead and we use the formula. That's a probability of both of these happening. But if it's both between 138 and 139 and it's greater than 138, that's no different than just saying it's between 138 and 139. So probability that X is between 138 and 139 divided by the probability that it's greater than 138. Okay. And 138, 139, I can pop these in. So between 138, 139, we want the probability, say mean and standard deviation, and there we go, about 0.055653, etc. Okay, and that's how I got this number. Then divided by the probability that we're greater than 138. So now we go ahead and we go greater than 138. And empty the probability, make that blank, and hit calculate. And about 0.61245. And there we have it. And when I divided that, I got about 0.09. So there's a 9% chance of it being born in the next 24 hours. Any questions on calculating these probabilities? Hey, I like these because they're pretty much fun and they're realistic, by the way. All right, ready for our one more example? Another kind of nice application. Okay, especially since it's been really warm here, so we can actually think about ice cream maybe. All right, so suppose that the amount of ice cream that you sell, so you have an ice cream shop, okay? And let's suppose that you've done some research on, you've looked at the data on your own ice cream, and the amount of ice cream that you sell is normally distributed with mean 950 ounces and standard deviation 120 ounces. So we could say X tilde N 950, 120. Find the probability on a randomly selected day you'll sell between 900 and 1,000 ounces of ice cream. Okay, so we want the probability that X is between 900 and 1,000. So we go to between 900 and 1,000. Our mean in this case is 950 and our standard deviation is 120. So 950 for the mean, 120 for the standard deviation. We want the probability, so I leave that blank and I hit calculate. And there's our probability, about 0.323. Okay, so not that small chance. Not gigantic, but not tiny. Any questions on part A? All right, part B. Okay, in the morning, you took stock of your supplies. You noticed you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? What does it mean to run out? In terms of your customers. Any thoughts? Okay, so the idea, okay, run out at 1,100, right? But what it really means is that your customer's needs or wants is at least is greater than 1,100 ounces, right? So you have your total number of customers that come in, a total amount of customers that come in, their total want is 1,200 ounces you've run out. Do you see that? Whereas if it's 1,000 ounces, you have enough for them. So we want the probability that we have the customer's, needs is greater than 1,100. So all I have to do is hit greater than, make that 1,100. Same mean, same standard deviation, and we find the probability. And there's about a little more than 10% chance, almost an 11% chance, 0.1056 or so. Any questions? All right. Now let's suppose you want to be 99% certain you're not going to run out of ice cream. Okay. Remember, if you own a business like an ice cream store and you run out of ice cream, people are going to come to your store. Oh, we don't have any ice cream left in our ice cream shop. They're going to be pissed off. And they're going to tell everybody on social media, whatever, don't ever come here again. So you really don't want that happening as an owner of that business. Does that make sense? Okay, so if you want to be 99% certain you're not going to run out of ice cream, how much do you need to have in stock at the beginning of the day? Any questions on the question? Okay, so on this one, we're given the probability and we want to find our value of X. So probability that X is greater than what number will give you 0.99. So then I go ahead, we have greater than. What number means I leave that blank? And the probability is 0.99. Any questions on that? And I hit calculate. And there it is. Okay. We need to have 670.838255 ounces of ice cream in stock to make sure we don't run out. Any questions on that? Oh, you know what? I went the wrong way. That's that's a that's a 99% chance of running out. If we don't want to run out, the probability should be 0.01, 1% chance of running out if there's a 99% chance of not running out. Sorry about that. That's much better. Again, I can always look at the answer and say that didn't make sense because it's got to be a lot of ice cream, not a little. And that's going to be about 1,229 and 0.16. So to the nearest ounce, 1,230. So stock 1,230 ounces of ice cream. Here's an interesting question. See if you put in the chat box the answer. What is the probability of having exactly 1,000 ounces sold? Exactly. See if you can put in the chat box the answer to that. Here's a hint. You don't need the calculator. Yeah. Yeah, the normal distribution is a continuous variable. When you have a continuous variable, the probability of exactly any number is always zero. It doesn't mean it can't happen, but it's so unlikely to be exactly that what's called limits to zero. So that probability is just zero. Any questions on that? You don't need a calculator to know that as long as you understand that exactly has a zero probability whenever you have a continuous distribution. Okay. All right. So I did promise this to be a little shorter. We're our last thing to do, which is the secret word. The secret word is a word that you guys weren't able to say when I started the webinar. Actually, it's funny when I said what shape is the normal distribution, and you didn't remember. So it is a bell shape, Bell, and that is the secret word for this week 4 webinar is bell. Okay. I do want to remind you on something, and that is this week, since it's such a pretty easy week in terms of the new material, make sure you make significant progress on your project. So, around a week from today or a week from tomorrow, I recommend sending me your rough draft so that I can look at it and give you feedback. Okay. Technically, you have till 8 in the morning a week from Thursday. But a little earlier is better. Then it won't take me as long to give you feedback, and you'll have more days to fix it. So again, this is when you should really spend a lot of time getting that project worked on. Okay. What happens next week? There's no material that you need for the project. So you are ready for it now. Again, if you don't have a partner, worry a lot. You need to have partners. So hopefully you all have partners. Okay, because you can't pretty much can't pass if you have no partners. Okay, even if you have a great project, it's still going to be, a D. So it's really important to have partners, and hopefully you can, get partners if you don't have them already. So that's pretty much it. Again, I mentioned this is one of the easier days. Hopefully you agreed. That changes. Um, Next week's a little harder than this week, not too bad. The week after and the week after that are pretty intense, really important though. Very, very, very used in terms of applications. So I think I am going to stop the recording. Let me double check something. Yeah, I'm gonna stop the recording.